This is Mrs. O'Neill for AP Chemistry, Chapter 6, Section 7, Many-Electron Atoms. So your objective in this section is to understand that these energy levels with more than one electron are a little altered because it contains multiple electrons. So we want to understand that. We want to understand that the last quantum number is spin, and Pauli Exclusion Principle came up with the idea that there are no two electrons in an atom that have the same 4 quantum numbers because, again, of the spin. And each of those orbitals can hold a maximum of 2 electrons. So far we looked at the hydrogen atom. So anytime I talked about the atom, I talked about a hydrogen atom, we talked about that 1 electron. Well, hydrogen is the only element that has 1 electron. Every other atom, every other element has more than 1 electron. So how do we deal with that? Again, I suggest to pause the video, fill in the blanks, and then listen to hear my words. So for atoms with many electrons, that energy level, the number of orbitals is also going to increase. So again, if we look at this energy diagram that shows these orbitals, again, I like this energy diagram where it shows you a little bit better representation of the amount of energy there is between energy level 1 and energy level 2. The amount of energy between an energy level, but within the energy level, like an S and a P. And then the amount of energy, again, a little bit more distance here between energy level 2 and energy level 3, but a little shorter distance between the 3S and the 3P. So I like that these diagrams are showing that more accurate. Then we want to remember, here's our first energy level. It only has one shape, the S, and it has 1 orbital, and in that 1 orbital, we're going to have 2 electrons. In the second energy level, it has the shapes of S and P. S, again, only has 1, but P has 3. And we want to remember that electrons are going to be filled up 1, 2, 3, and then double up 4, 5, 6. Okay, so then if we get to the third energy, ooh, look at this. This 4S orbital is actually in between the 3p and the 3d. Why is that? That's because it has less energy than the 3d. So when you guys did your electron configurations in Honors Chem 1 or in Chemistry 1 academic, which we don't really get to, that electron configuration, you probably used what was called the diagonal rule to get you to understand where these electrons are. And again, we want to talk about probability, where those electrons are most of the time. Well, this is that same electron configuration, energy diagram, and how those electrons are being filled. But one of the reasons why you did the 4s before the 3d is because of the amount of energy it has. So you might want to pause the video, read these questions, see if you can answer them. So hopefully that makes sense. Hopefully that makes sense that there's 1 orbital in the 3s, there's 3 orbitals in the 3p, and there's 5 orbitals in the 3d. And we want to remember the amount of electrons. So the 3s will have 2 electrons, the 3p is going to have 6 electrons, and the 3d is going to have 10 electrons total. And hopefully you understand now the amount of energy. So your 3s is going to have less energy than the 3p, which is going to have less energy than the 3d. And that's how we fill up those electrons, or that electron configuration. So there's Mr. Pauli, and he came up with the Pauli Exclusion Principle. And he came up with the spin first. That's where he got the idea that no electron has the same 4 quantum numbers. So those 2 electrons that are in that orbital are going to get a value of +1/2 and -1/2. And of course, we show this just by the arrow up, arrow down. That's what you really need to understand. You need to understand that those 2 electrons in there are going to spin oppositely, and that's why they have different quantum numbers. So again, it states no 2 electrons in an atom have the same 4 quantum numbers, and each of those orbitals can hold a maximum of 2 electrons, but they're going to have opposite spins. So what do you really need to know about these 4 quantum numbers? Well, they give us the location of each of those electrons. And again, location is really the most probable place. 90% of the time they're in their ground state. Where is that? Where is that 1 electron going to hang out most of the time? So the first quantum number deals with that energy level. 1 through 7. The second energy level dealt with shape, the S, the P, the D, and the F. And we want to remember then those shapes have a different amount of orbitals. So your third quantum number dealt with orbitals, and those are those boxes, or sometimes they're just lines. But we want to remember that the S is going to have 1 orbital, P has 3, D has 5, and F has 7. And again, 1 orbital, 2 electrons. So the S's are always going to have 2 electrons max. P is going to have 3 orbitals, meaning 6 electrons max. D has 5 orbitals, 10 electrons max. And finally, F has 7 orbitals, so 14 electrons max. And again, our spin, the last thing is spin, and that's where Pauli comes in and says, hey, these 2 electrons that are sharing that same orbital really are going to have opposite spin. One's going to spin this way, one's going to spin that way. And think about that. That kind of makes sense because they repel each other. They're both negatively charged, so those electrons are going to repel each other. So they're going to spin in opposite directions. And that's where that arrow up, arrow down comes in. So this is the information that you truly need to know and understand. Don't worry too much about the values that are given to each of those quantum numbers. Okay, see you in class.